Okay, let's go ahead and get started on this there, folks. One second, let me go ahead and get the Chrome set up here. There we go. And I see that Blackheart is available in the stage. Let me go ahead and invite him to speak. There we
Hello
go.
there, Jim. How you doing?
Not bad there, Blackheart. Not bad. Um, I forgot my typical intro.
No problems there.
Oh, well, it's okay. Um, yeah, but hey, welcome everybody to our tutorial series for Unreal, or us trying to learn Unreal Engine. We're going through a lot of the topics that we feel are going to be necessary for us to build not only a clone, you know, directly afterwards, but you know, our own games moving forward. So the first topic that you know we're covering right at this moment in time is the audio, which, as you can see, there's a lot. Um, so and here's the thing, we might be dealing with a lot more as we proceed onwards right at this point in time. Now, we haven't really had a need to go um, uh, like build anything like definitive yet. Using our examples here, maybe a little from time to time, but for the most part, not really. Um, oh wait, we did not get through all of the native Soundfield ambisonics, if I'm not mistaken, right?
No. No, we went to up to Ambisonics in Unreal Engine, and the next part was gonna be importing and playing an ambisonic audio asset.
Right,
A part we didn't have time to look over.
right. I was almost going on to the next session altogether. It's like, wait, no, we still have a little bit more left.
Yeah.
So, although from what I can see, or from what I remember, we took a look at you know this upcoming section, and it's looking like it's fairly jam-packed with information, and hard to say whether or not we're going to be um, understanding. Some of these topics we've come across, and we're like going, oh, okay, this is a little too much for us. Being that we're programmers, not sound engineers.
Nope.
Um, but um, we'll do what we can. You know, we'll have to probably put on those hats when the time comes. But for now, um, we can only do so much. So,
Yeah.
okay, shall we get started?
Yeah.
Okay. So, importing and playing an ambisonic audio asset. So, with the release of version 4.25, Unreal Engine only supports first order ambisonic assets. Okay. How
That
that
doesn't tell us much.
yeah, it's like, okay, is there other orders? Well, whatever. We'll see. A first order ambisonic asset has four channels: the omni component, or W channel, and the vector components, or X, Y, and Z channels. Okay. Again, not really telling you too much, although I mean we're we're aware of um what was it again? It was the wasn't necessarily ambisonic. Um, they gave a word that I wasn't quite sure about before. I was wanted to kind of look it up, and I'm missing the word now.
Mm.
Ah, there it is. The azimuthal
All right.
or as azimuth. So, um, so if it's along those lines, or if it's kind of similar to that, then I can kind of understand the X, Y, and Z channels, and that it's kind of when you do X, Y, and Z, not only are you doing the horizontal and vertical, and the you're talking about uh, the X, like maybe right in front of you, the Y off to your side, and then your Z is like up or down, right?
Yeah.
Um, you know, Although in some graphic settings it's a little bit different than that. Sometimes it's like um, X is to your side, Z is right in front of you, and Y is the up and down. Whatever. It I've seen so many different combinations or differences of those that I'm never quite sure um, what people interpret from time to time. So,
Mm.
um, so I can't say for 100%, what direction is, definitive, this is how you need to look at it. So, but I don't know what this Omni component would potentially be, you know.
No, not
So
sure myself.
maybe maybe it has something to do with like the wave itself, maybe like the hertz or something. I don't know. Maybe they'll explain a little bit more later.
Hopefully.
Maybe. Okay, Unreal Engine supports two channel orders. FUMA or first Malham Ham and ACN ambisonics channel number. Okay. The FUMA channel ordering sequences the ambisonics audio channel components as W, Y, Z, and X. Okay. For what reason is my question on that, but maybe they'll explain later. We'll see. The ACN channel ordering uses WXYZ. So, again, not sure why they have like the different orderings there, but you know,
Maybe in the order from which they pick up the information, maybe?
um, maybe, or how they use the information. But again,
Yeah, like to determine where it is, where the audio is, maybe, since that's to me, so when you talk like X, Y, Z, it's sort of like a coordinate on a grid.
right. Um, yeah, but still, it's one of those things where it's like, what does it matter the ordering? What's the difference between the two? Um, which they haven't addressed,
No.
and we'll have to, maybe they will address it later on, and then again, maybe not. We'll see. Um, since first order ambisonic audio uses four channels, uh, any imported file that does not have four channels will be treated as a normal non-ambisonic audio asset. Okay. Um, and how does it, you know, what does it do for, hey, you're being treated because you only have three out of the four channels. Okay, how does it interpret that? You know, I don't know. Just one of the questions in my mind right at this moment in time. You know, who knows
Yeah.
if we're going to be getting an answer, so we move on. To import an ambisonic WAV file into the content browser, you should end the name of the asset with either underscore FUMA or underscore ambix. If your ambisonics file uses FUMA channel ordering, or if your ambisonics file uses ACN channel ordering. Um, this will tell the engine what the channel order of the original ambisonic asset is. After dragging your file into the content browser, when you open the Soundwave asset, you should see that the Is Ambisonics checkbox is already checked in the Soundwave Inspector panel. Okay. So just having those two tags at the very end of your file will automatically select ambisonics,
The
huh?
order. Yeah, the
It,
order of which ambisonic it's using.
well, I mean, it just says like, hey, this is indeed an ambisonic just because you have those particular tags at the end. So that's interesting.
Yeah.
Um,
That's not only there to tell it this is ambisonic, but also what order to give the information to that ambisonic.
sure. Seeing that they have, the different orderings of WXYZ or WYZX. So yeah. Um, if you forget to end in the name of your file with Amex or Fuma before you import the WAV file, you can still check this box yourself. The engine will assume that the original file you imported using ACN channel ordering if you do this. Um, oh, okay. So if you don't have like Fuma at the end of your file, for example, the engine will default to ACN, and there's really nothing that you can do about it with that.
Yeah.
So
Yeah,
if
like adding those is more of a safe measure to ensure it uses the right order and not
right,
the default.
exactly. So after your Emersonic file is imported, you can treat it like any other sound file, a sound wave in the engine, with the important exception that rotation matters. When you play back an ambisonic sound wave via an audio component in the world, the engine will rotate the ambersonic's bed based on the rotation between the current rotation of the audio component that is playing and the current rotation of the player in the game world. Huh, okay. Um, engine will rotate the ambersonic's bed based on the rotation. Hmm. Will rotate the ambersonic's bed based on the rotation between the current rotation of the audio component that is playing, the current rotation of the player in the game world.
Rotation of player
Hmm.
in the game will kind of make sense to me 'cause it depends. Okay, you're looking in one way, you're gonna hear the sound in that direction. As
Yeah.
for the rotational of the audio, that one is
Well,
what?
I mean, in that case, it might also make sense. Like if you have like someone playing a loudspeaker, or someone like has like you know um, they have like music playing off their phone or something like that, and they're just kind of walking down the street, right? Um, the speakers on their phone is kind of directed in in a certain direction, right? So
Yeah,
if it was like facing you, then you'd probably hear it a little bit clearer than if it was like facing away from you.
yeah,
So there's that rotation as well. Is it
like directional sound, pretty much.
right? So is this covering that in this particular case?
Well,
Um,
that's what making it sound like. If the sound's going this way and the player's facing in a specific direction, it's going to determine. how you're gonna hear the sound and which side you're gonna hear it.
Right. But again, we come back to our original question as to, what's the difference between FUMA and ACN? Why does it matter why you have different orderings,
Mm.
what exactly is both of them differing from? Is there some form of mathematical computation that makes like FUMA over better than ACN? Is it something along the lines of like we only care about typically W and Y for FUMA over the Z and X, so we don't really like it. We get the W and Y and we're pretty much happy. We don't need to worry about doing any kind of calculations with Z and X, and there you go.
Mhm. The order is just to me, it's just in it the sounds in this location. As for the difference between one and the other, I think they're just expecting us to know a bit of sound engineering and how the particular softwares that work with this work actually differentiates from each other.
Well, that's my point though, is that they're not really addressing it themselves as to, what the differences are, here in this tutorial. You would think that, yeah, it would be nice if they did, if they kind of gave you some clarification as to, what is the purpose of these two channel orders. But they didn't, so it makes me kind of curious as to what that's all about. But again, that's something that we may need to kind of worry about when we get to the point of adding audio into our clone and game later.
Mm.
But for right now, we probably could go ahead and skip it, I guess, for now.
Yeah.
But it might be something very important later on down the road that, it's like, hey guys, it'd be nice to have a little bit more information along those lines, on this page to know, what is, um, these two orderings. What is it all about? You know, does it even matter? And if it doesn't even matter, then what's the purpose of even having these two channels? It's like, you would think that um, you know, uh, if it didn't really matter, then there'd only be one channel ordering and that's it. You wouldn't even need to really discuss it, right?
Mm.
So that's why it's like, what's going on here? What is the purpose of these two, and why are they different? That's it. That's my mentality right at this moment in time. You know, they wouldn't make those different orderings if there was some kind of purpose to it, but they're
Mm.
not
Yeah,
giving
maybe
us
those
that purpose.
purposes just determine what order it handles the sound.
Yeah, possibly. Again, don't really know. Obviously, if anybody knows, directly, like if you're a sound engineer, you've dealt with this before, feel free to like leave a comment in our chats right now during stream, or leave a comment on our videos as we upload them to our respective channels. So help us out with that. If you are aware, it'd be helpful. But we move on, shall we?
Yeah.
All right. So in addition to playing back ambisonic sound waves like you would any other sound wave, you can use ambisonics directly in the submix graph. To do this, you will need to create a Soundfield submix. Okay. Um, that's what exactly is a submix graph? Um, okay. Soundfield submixes can be used and connected to other submixes in the submix graph, but are able to use any Soundfield representation currently implemented in the engine and implemented by a current enabled plugin. If you open your newly created Soundfield submix and look at the inspector panel, you will see a drop-down menu for Soundfield encoding format that includes Unreal Ambisonics in as one option. Okay, once again, we're getting hit with information that might be relevant. Obviously, a sound engineer might know, but you know,
Yes, this would be more for sound engineering, maybe.
yeah,
When it mentions like a graph, it makes me think of, and how some players you could see the bars going up and down for certain sounds based on what sound was playing. Kind of makes me think of that, maybe something
maybe.
similar to that.
I mean, when I hear submix, I think of a mixer, you know, where you can kind of adjust, um, certain heights or certain loudness of, the music coming in or the sound coming in.
Could be
Um,
that, really. You can
so
see probably the graph and you can alter it. Like, okay, this part of the graph needs to be a little lower. Maybe this part of the graph needs to be a little bit higher.
yeah, and then you can kind of change like um, the sound wave a little bit to, make, um, like, if you wanted the like a voice actor to be a little bit more robotic, for example, you could probably try to, change the sound file in such a way where it's like, you add a little bit more, or you like change the pitch or something, whatever,
Yeah.
to mess with it or something like that. I don't know if that's this though, because again, I'm not really, when I look at this, they're not giving me that kind of information like you would see a normal mixing board.
No.
Um, so, um, hmm, I don't know. I feel like we're getting into a little bit more information that might be kind of beyond our understanding, and we might get to a point where we're going to be more confused than anything else. What are you feeling right about now? Shall we go ahead and continue, or are you feeling like maybe we should back out of this?
Mm, I'd say that for now we back out of it because this is starting to step into something that's more for sound engineering than anything else.
Okay. Yeah, because I mean
Just
they're
for
they're
now.
yeah they're pulling out the blueprints and showing like, hey, my ambisonic submix is connecting the output to the input of my resonance submix, and it's like, okay, well, what is, what are these, kind of thing. But they're not really giving you any like, definitive information about it. So, um, like when we, obviously, if we have to get to this point where we need to use this more, um, then obviously we'll need to do a deep dive on it. But
Yeah,
for now, I think we might need to. I think we might also need to kind of back out for now.
for now. Yeah.
Not to
Like
say
we
that.
know what ambisonic technically is, we just not entirely sure how to apply it ourselves.
Yeah, you know, we can kind of get it. It's like right there. It feels like it's like okay, in some ways we're understanding the descriptions that they've kind of given to us a little bit with it already, but um, there's just some parts of it where it's like, it kind of goes beyond our current understanding. So we'd
Mm,
have to we'd have to really kind of do a deep dive on that to make sure that we're like fully comfortable.
yeah.
So that's all. All right. Shall we move on to sound classes then?
Yeah, let's move on to that.
Okay. Now I see here, right at the very top of sound classes, that it is advanced. So we might be once again encountering information that is like beyond our understanding. But you know, we'll see.
Yeah, there'll probably be a few things that we won't understand. Yeah.
Yeah. So sound classes, an overview of the Unreal Audio Engine sound classes. So we shall proceed because we got 25 minutes left in this
Yeah.
hour. We got time to
Yeah.
at least check this out. So, and it is a fairly lengthy topic, but I mean, there's also a lot of images and stuff like that, and it looks like a lot of it's kind of just talking about like definitions and stuff like that
For the
of
most part, yeah.
of topics. So it feels like it's just kind of going over, what is included in a sound class. So,
Yeah. And as I believe something we'll probably want to get into a little bit, considering that we did have to make one sound class for like the ambient stuff, for instance.
right. And obviously we're probably going to be needing that for like uh, you know, other features, or other sounds later, not just ambience, but,
Yeah.
you
Sound
know,
effects,
right,
music,
right. So,
and other stuff.
yeah. A sound class is an asset type for the audio engine within Unreal Engine or Unreal Engine 4 that a user can use to group multiple sounds together. Then alter the parameters of all relevant sound waves at once. Okay. So if like you have, multiple sound waves all kind of combined into one, and you need to say, hey, I need to lower the volume of like everything, you know, like you're traveling away from, you know, a certain scenario or something like that, then you need to kind of reduce down that overall sound, right? Um, so maybe that's what they're kind of going with there a little bit. But
Mm.
using sound class mixes, many sound class parameters can be adjusted during gameplay. During gameplay? Interesting. Um, to set up a new sound class, right-click from the content browser, then select Sounds, Classes, and Sound Class. Right, we've done that. To open the details panel for a sound class, double-click the sound class in the content browser, which we've done. So general properties. The first set of properties in a sound class are the general properties. So they're showing volume, pitch, low pass filter, frequency, attenuation, distance scale, always play, child classes, and passive sound mix modifiers. Now this probably has been changed, um, on our current, 4.7. I don't know
Yeah.
if it
Well,
has.
I can always open one of mine and compare it.
We might want to consider doing that actually, just to kind of
On it.
show, you know, like show the difference because we know, we've already seen some differences already.
But some of these, yeah, some
You
of the
know,
ordering might be different.
yeah. So, um,
Okay. Let me open my sound class and of course put OBS to show it. There it is. And okay, the general one is still the same, fortunately, by the looks of it. Yeah, the first one, the general one, is still the same. Even the variables are still the same.
Okay, hold on. Let me adjust here real quick. Mm, there we go. Okay, and now the details are on the left-hand side, so I'm going to move my Chrome over to the right-hand side so everybody can kind of see that. Matter of fact, I think I'll do the same with my webcam. Whee! Okay, okay, so let's see what we got here. We got volume, pitch. Here, let me open this up a little bit. We got volume, pitch, low pass frequency, filter frequency. Yeah, let me give it a little bit more room here.
Attenuation, distance scale, always play, child class, and passive sound mix modifier.
Right. Okay, so let's go through each of these, making sure we're good on that. So, volume, a multiplier on the loudness of each sound within the class. So you can have multiple sounds kind of combined in with that one single class. So good to know.
Hmm.
This acts on top of volume settings in the sound wave object itself. Okay, so there's that. This acts on top of volume settings, so that's interesting. Um, doesn't necessarily override, but it adds its own multiplier in.
Hmm.
So you could technically have like a single multiplier in the sound wave object, but you might have like double the volume or two times the volume multiplier for the sound class. So so that's interesting. Um, okay. Pitch, a multiplier on the pitch of each sound within the class that acts on top of the pitch settings of the sound wave object. So same as the volume there overall.
Hmm.
So um, now I don't know personally what like the major difference is. Like what affects pitch or what if um I personally don't know like, oh yeah, you're changing the pitch. I'm like, okay, what exactly does that mean per se? Like, what's happening to the audio, right? Um,
My little understanding of pitch, like, how should I explain this? Um, how the pitch could determine like how deep the voice sounds or how um high the voice sound. I don't know if you heard like those like slowed down songs like that. It pretty much does takes its pitch and brings it down to something like the voice sound different.
let's see. Let me go ahead and um,
Like I'm talking right now like this. If I raise my pitch, I would sound a little bit like this, and then if I lower it even further down below, I would sound something quite ugly. That would be just me altering my pitch on my throat, pretty much.
yeah.
Pretty much, so I sound like a a giant's like deep voice, or do I sound like a squeaky mouse?
Okay.
That's from what I little understand of what pitch is simply referring to.
Yeah. I think. Yeah. I mean, yeah. Um. Okay. I'm also taking a look at the um um. I just looked up what sound pitch, through Google,
Yeah,
and I am also noticing that um how many like um how many waves in like a second kind of thing. Like say like you have four waves in a second, right? If you if you lower the frequency or making it like only two waves a second, you're making a lower pitch. Whereas
yeah,
if you increase the number of waves, meaning that you go from like four to say eight, you're you're creating a higher frequency you know or a higher pitch based
yeah.
off of what I'm seeing here. So um, I think to really solidify that, I'm gonna need to like I'll go online and I'll confirm what
Like,
you were kind of
how would
going
that
with.
sound? Like I said, the higher the pitch, the more like a mouse you will sound. The lower the pitch, the more like Darth Vader you will sound.
Indeed, indeed. Well, I don't, I don't know if um, we have to be careful with that, okay? Because I don't know if, okay, for example, when you're talking about singers, for example, you hear about sopranos, you hear about tenors, you hear about baritones, you hear about basses. You know, um, does that, refer to their specific pitches? Like they always have a certain pitch to their singing voice um, that changes what you're hearing, or is it something else that kind of goes into that? Okay, so we got to be careful with that. I get what you're saying with changing your pitch, it goes from like, high squeak to very low tones kind of thing.
Yeah.
Um, but
Yeah, if you were to put those sounds through like a sound wave, you would see the difference in the waves.
right, but do you you know so you can modify your pitch along those lines, but I don't know if that has a correlation with like saying that someone is a soprano. Does that mean that they only have a certain pitch that they can sing at? Like they can only do, you know, a certain range of sound waves to achieve that soprano um, voice? I don't know if that uh, it might be like a different topic altogether. So we got to be
Yeah.
careful with
Well,
that.
in the computer running through software, the amount of pitches you have is almost infinite.
Well, yeah, yeah, no, no, I get you on that. But what I'm saying is that we got to be careful with, uh, you know, we like I don't want to automatically assign like Oh yeah, sopranos, they're just a different pitch. I don't want to make that judgment at this particular point in time because I don't know if that has the same um, relation with each other or not. You get what I'm saying? Like you can take a soprano's voice and still change their pitch. You can, turn the knob and, change that soprano's, high, well, I guess high pitched, sound or singing into something that's very low or,
Yeah,
something along those lines, right? You can
yeah.
change that, but is
That's just pretty much what this will do. That's pretty much what this the Unreal is going to do when we you alter that.
right. But my
It won't care what the base pitch is. If you alter that pitch, it'll sound what you as you altered it.
Yeah, my question though is that should I consider like tenor a pitch? Now, my brother would
That
probably
will depend on what we're gonna make.
well, my brother might actually answer my question along those lines because he studied music theory. So, he probably knows, I mean, he would definitely know more than I would along those lines. I
Yeah,
mean, he was
I
a
would
tech.
say the pitch here in Unreal, if we were to think in a more practical sense, if we made a character, but our voice actor can't hit that pitch, then through Unreal we would edit it and we can get the pitch that we think would fit the character, regardless of how the voice actor sounds.
Well, I mean, hell, if we really wanted to, we can probably make anybody like, chipmunks, you know. Um,
I mean, that's what they did with Alvin and the Chipmunks movie.
Pretty much. Um, you're not getting, and you're not making them, you know. I mean, today's voice actors might be able to do it themselves, with a certain amount of training
No,
and stuff like that. They might be able to, but I mean, what's the point when you can just, modify it, through technology, right? You could just have someone just speak regular lines, and then you have the sound editors going, okay, we need to change it up, to Alvin's standards, um, whatever,
yeah,
right?
there are very few people that can pull that off of changing their voices. There is this one YouTuber, I can't remember his name right now, but uh, the guys from the Cleveland show actually saw his channel, heard he could change his pitch to sound like Cleveland, and they hired him for that.
hmm but that's the point is that
He
you know
can do it himself. He was able to do Cleveland, Trump, Joker.
yeah, some people are able to, you know but not everybody can.
Yeah,
So
that's why
um
most of the time they rely on softwares.
yeah,
It's not something easy to pull off.
no, no. So um I mean, like you were saying, the original Alvin and Chipmunks was just, just regular voice actors giving those lines, and then they changed um,
The pitch.
the pitch on those. So, but yeah, I'll have to talk with my brother on that and ask him directly, you know. So, but I'll worry about that later. Okay, low pass filter frequency. The cutoff frequency for a low pass filter that impacts all sounds within the class. A value of 2000, 20,000 or above has no effect on the sound wave. Okay, I have no idea what that means.
Not entirely sure either.
What is a low pass filter? What is the cutoff frequency? Obviously, you know, it impacts all sounds. That's great, but you know, what exactly are they?
No, no.
Yeah, so that's something that we'll probably need to kind of look into a little bit more because, or we'll need to look into more later just to see like what if um if we want to have some kind of sound um, being affected in some way. Like
Mm-hmm.
maybe we want more of like an echo going on or something like that. We're gonna need to study this a little bit more to know like what do we need to change to make the sound, you know, being more of an echo sound than anything else. Like, like, hey, I'm going to clap, but you want it to kind of be, something that, sounds as though that it was like inside a cave or something like that, right? Or whatever. So, so yeah, it's one of those things where it's like, what exactly are each one of these things doing, and how does it affect that sound wave? That's something that we may need to study more later. Not saying we need to study it now. I'm just saying, like, um, if we're wanting to get more of a um, like we're we find an audio file and we're like on, okay, well this is good, but maybe we can create it to be something different for our own purposes. Like hey, let's say we want to create, like a laser blast or something like that. Like, someone's using a laser gun to shoot, right?
Mm-hmm.
Um, Now, obviously, you have the default laser sounds that are out there and stuff like that, but maybe we want to make a different spin on it or something like that. We want to change it up a little bit, you know. So, we use one of those features to maybe try to improve upon it or something, you know. But obviously, we don't know, you and I don't know a lot about sound engineering to go, oh yeah, you're going to be needing to do this to pull that off, right?
Mm-hmm.
Um, so obviously, as we progress, once again, we may need to put on those hats to basically say, okay, we are we are the sound engineers on this game, so we will need to, figure out what we need to do to
Yeah.
get the right kind of sound that we want for that particular case. Like maybe we're trying to play a sound, but it just doesn't sound right. Like maybe it hurts our ears or something like that. It's like maybe too high pitched or something like that. So we need to like lower the pitch, right, for that particular
Yeah.
sound to kind of get what we're looking for. And we may need to play around with it more
Mm.
to get what we need, um, but yeah, obviously we have no idea what low pass low pass filter frequency is all about. So, but we may need to go back and study that later. Not now, but later. So, attenuation distance scale scales the attenuation distance of each sound within the class, allowing for attenuation settings to be adjusted dynamically. Okay. What was the definition of attenuation again?
No, we missed with
Attenuation.
attenuation at one point, but with the audio volume,
Um,
no, it was on the sounds within outside the audio volume. It was, I believe.
yeah. The reduction of the force, effect, or value of something. The reduction of the amplitude of a signal, electronic current, or other oscillation. So,
I
um,
guess in this case, the attenuation will be the further you are, the less you hear it.
yeah. Well, the sound wave will reduce in size over distance. Um, so this affects like you know everything, or all the sounds that are associated with say class. It will be affected by this distance equally. You know,
Mm-hmm.
so which it um, hmm, we got to be careful with that a little bit because like some sounds might be um you know, some sounds might be like louder overall, but again, the attenuation might be, it might affect them all equally anyway. Um, I mean, unless
It'll
you,
affect whatever we attach this class to.
yeah, I mean, unless there's like a way to have like sound like travel further no matter what. But I haven't really heard about that too much. I mean, obviously, the louder a sound is, the further out you can hear it, right?
Mhm.
Um, but I wonder if there's like something where it's like, hey, you have a sound that will travel farther no matter what. Um, like, I mean, isn't radio a form of sound? I know obviously you have radio waves, but a form of sound. I mean, I'm just kind of curious.
Radio waves is a form of like electrical signal, not sound exactly.
Radio waves differ from sound waves because radio waves are electromagnetic waves and sound waves are mechanical waves. Interesting. Okay. Hmm, okay. Yeah, I was kind of curious about that, along those lines, and seeing, obviously they had, similar, I guess you might say, properties in the sense of like, you have, they're both waves in a sense, and you could
They're
still,
represented in a similar fashion, but they're
right,
not really the same.
right. So, um, but I wonder, you know, see, mechanical waves. Um, what are mechanical waves for dummies? um, some waves can only travel through a material or medium, such as air or water. These are called mechanical waves. Sound waves, water waves, seismic waves are all types of mechanical waves. Interesting. Okay. Good to know. I mean, I wasn't, you know, in particular knowledgeable definitively about that, so, you know. Okay. Um, yeah. Okay, we move on, shall we?
Yep.
Okay.
Yeah,
Well, we're getting close to the end here, so we'll do the always play here, and then we'll save the child classes for next time, shall we?
sure.
Okay, so always play. When enabled, it prevents sounds within the sound class from being ejected from the voice pool by sounds with a priority lower than always. Wait, what? When enabled, it prevents sounds within the sound class from being ejected from the voice pool by sounds with a priority lower than always. Hmm. That's
I guess it's in the case that you have like background noise going on and you want another sound effect to play on top of that so that the sound doesn't get interrupted in any way.
It just seems kind of odd that um, um,
That's
like
how
you,
I perceive.
yeah, it just seems odd to me. Like you would have, like if you put like two sounds into the sound class, right? And um, one sound has a lower priority, then it just gets removed or ejected in this particular case. That seems a little odd to me that they have that within like the same kind of class. You would think any kind of sound that you add to a sound class would be something that you'd want to obviously be playing like all the time no matter what. So having a sound being overwritten by another sound within the same sound class doesn't make that much sense to me personally, but I don't know. Just hmm, I'm not sure.
I'm not sure either.
Um, maybe there's something that um you can do or something like that. Maybe there's something that like there's something there that will allow for you to do that, but it's like what exactly would that circumstance be? It'd be nice to have like an example of what they're talking about here in this case. Like, what did they mean by having a sound ejecting another sound within the same class? Um, hmm. I can understand it like if you have like a
I guess this will work within the sound class only, probably. Like if you have within the same sound class two different sounds, but one of those sounds need to constantly be going, none of the children can actually interrupt that sound. I guess this will only apply with sounds within the sound class itself.
well, I'm not sure because I mean this is the um this is the general details. So does it apply to all the sounds associated within the class itself, or does it kind of attach itself to the sound that you are like attaching it towards, like the ambient sounds, for example. You'll always play those ambient sounds. Um,
Yes, that it is just as I saw. I just went into the into my sound class and I created a new sound in it, like a new sound class within it. And the ambient one I put always plays. When I select a new one, always plays is not selected. So this will affect whatever is inside the sound class itself.
only affects what's inside the sound class, not necessarily the sound file or the ambient sound.
No.
Okay.
Like if you look at the image like below, you got those two sound example sound classes. They both have their own respective general. They don't share the same one. That's when I saw when I added one on mine. I already deleted it, but like if I select the first example one, I put always play. Then I select the second example child class. That child cannot interrupt the first one. If I don't select the always play, then the child will interrupt the first sound class.
Mm-hmm. Okay. Interesting. Okay. Well, we'll have to cover more of this tomorrow. Or actually, no, not tomorrow. Tomorrow's
No,
your day off.
tomorrow
Um,
for the time is my day off.
yeah. And Thursday might be a day off for me because it's United States Thanksgiving. So
Right, right. Yeah,
so
so I won't schedule for Thursday.
yeah, so I might be out on Thursday myself, like completely.
Mm,
So
don't worry about it. I would just won't schedule anything that day for Unreal.
yeah, so just
Yeah,
giving you
no
a little
problem.
heads, giving you a heads up on that one.
Yep.
Obviously, if things change, then I'll let you know. But um, I have a penciled in engagement right at this moment in time. I
Yeah, no
have
problem there.
so um, so I might not be, you know, able to stream on that day.
Yeah, yeah.
So um, but yeah, I think that's gonna be it for today. So let's go ahead and like close on out, and then you go get yourself something to eat. I'll upload some videos on my end, and then we'll play some Troya later on tonight.
Yep.
So, okay,
All right.
bye, man. You have
All
yourself a
right.
good time. See you in a little bit, and
See
talk
you
with
in
you
a little
later.
bit.
Bye.
Bye.
Okay. So yeah, that's where we're gonna go ahead and end this Unreal session. So I want to thank you all for joining me on this. Hopefully, um, you found it informative in some fashion or another. But obviously, Blackheart and I had a little bit more questions than it felt answers at this point. Um, we'll have to, um, I'll check with my brother about the whole um, pitch and tenor and so on and so forth, and see what he has to say about that. Um, and then we'll go from there. But yeah, that's gonna be it for that. You know, if you're watching these videos and you have answers yourself, feel free to put them in the comments. Um, or come by our streams and chat with us directly if you want. Um, both are reasonable solutions to that. So, but that's where we're going to go ahead and end this session. So, help me out with the YouTube algorithm. With a like and subscribe and all that jazz. That would be fantastic. Um, check out the description for other links, such as social media, links that help me out directly, or my stream team. Check out any of that if you're interested in what I have down in the description below. Um, and yeah, that's gonna be it. So thank you very much for watching. I appreciate it. Hopefully I catch you next time. But until then, take care. Have a good night. Stay healthy. Stay safe. And I'll catch you strangers next time.